Anyway, there are a couple questions here that turn out to be duplicates. And so I'm going to skip some of the problems because we'll see them again later on. Okay, here we go. In the notation up here in the directions, remember that study guides are not guaranteed to cover 100% of the quizzes. You should be able to do any of the problems in the packet anywhere. Remember that quiz questions can be reworded, flip-flopped. Remember that retaking a quiz oftentimes means different questions. The numbers will be different. Instead of a car going 50 miles an hour in the first quiz, now it's the car going 70 miles an hour in the other direction on the retake, that kind of thing. On the original test, there might be a train, but on the retake, it's going to be a plane going in a different direction. It's the same kinds of questions covering the same topic, but worded differently. On the original quiz, it might be a true false. On the retake, it might be multiple choice, that kind of a thing. Also remember, on retakes, your more recent score is kept, not the better of the 2 or 3. You get 2 extra attempts. After the original, you get, when I tell you when to do the original, the next 2 you can do on your own whenever. All righty. Number 1, a speedometer shows how fast you are going as a positive number. Velocity can be positive or negative. What does the sign mean? Circle your answer at this time. How fast the object is going, what direction the object is going, what side of the origin the object is on, whether or not the object is happy. The answer is what direction the object is going. If it is positive, that means that it is going to the right or it is going up. If it's negative, that means it's going left or it's going down. Number 2, what does triangle X mean? Is it the final location? Is it the initial location? Is it the change in location? Please circle your answer right now. You've seen the triangle before in chemistry class. It was triangle T back then for the change in temperature. So delta X or triangle X is the change in the X location, change in X, change in location. So I just said, oh, next one is triangle V. We have that variable in the equation A equals triangle V divided by T. What does this triangle V mean? Circle your answer. Every triangle that I've ever seen in science means a change in something. So in this, the change in V or velocity. In other places, in other math classes, it might mean something different, but in physics, I've only seen it as the one meaning. Okay, next, number 4. Let's see here, I gotta make it big for my old eyes. What does X sub F mean? I could also read that, what does X subscript F mean? Circle your answer. And the F stands for final location. X sub I. We should know that because we've done the other 2 options already. The I means initial. We'd read that as X sub I or X subscript I, or just simply initial location. Number 6. Sam is located at positive 5 meters. What does this mean? Does it mean A, he's either above or to the right of the origin? Option B, he's either below or left the origin. Or letter C, he's either to the right or to the left of the origin. What does it mean? The answer is, he is located either above or to the right of the origin. Number 7, Sally is moving at negative 7 meters per second. What does that mean? Go ahead and read through those options and circle your answer. The unit here is meters per second, meters over seconds. So that tells us that it's a velocity, not a location. So A is out and D is out. This does not tell us anything about location, only about the motion, the velocity. Okay, the negative means left or down. So I want to make sure you guys understand that the positives and negatives mean completely different things when you're looking at the X's versus the V's versus the A's. With the X, here, let's clear out some of this stuff. When it comes to, let's see here, let's put down variable and the sign. That's not quite right. Let's try that again. When it comes to the X, the positive and negative sign means what side of the origin the object is located. Is it currently on the left side or the right side? We do not know which direction it's moving. It doesn't matter. That doesn't affect the sign of the X. All that we're worried about is on what side of the origin would we have to look in order to find the thing. Okay, then the V, its sign tells us which way it is moving. Is it moving to the left or is it moving to the right? It doesn't tell us anything about where is it located. Is it over here or is it over there? Well, we don't know, but we know that if it's moving left or if it's moving right. It could be way over there, moving to the left, or it could be way over there, moving to the left. We don't know. It's just the negative sign would be moving to the left. Okay, and then we have the A. With the acceleration, the positive and negative just means what direction is it being pushed on. Push in which way, which direction. The push is in which direction. Now remember, if a car is going that way, it could be pushed on in this direction. No, if the car's going this way, it could be being pushed backwards, or it could be pushed on this way. So the direction of motion is not involved necessarily in the sign of the acceleration. It's just which way are you pushing on the car? Are you pushing on it backwards or are you pushing on it forwards? That kind of a thing. Okay. And more specifically here, is the pushing towards the left negative side, or is it being pushed in the positive direction to the right? Let's see here. Just because a push to the left is going to make some things go faster and faster, and it's going to make some things go slower and slower. Here, I have my little Viking guy. Okay, so if he's going this direction, but I'm being pushed here, this is a push to the left. This would be a negative push. So the guy going like this, being pushed like that, he's going to get slowed down to a stop. So in this way, a negative acceleration is going to slow him down. But if I have the Viking guy going this way, and now I'm pushing like this, the same push, same sign, now makes him go faster and faster. So the pushes of positives and negatives do not mean that it's going faster or slower. It just means which direction he's being pushed. Okay, I hope I've said that now several different ways and different times. Let's see if that works. If not, remember that there are the videos of the previous lessons and there's readings in your packet that explain things, and maybe going over those over a couple times will help out. Otherwise, give me an email. Okay, enough of that. We went up through number 7. Number 8, we're going to skip for now because we see it again later on in more detail, broken down into individual little steps. Number 9 is also done again later on. Let me just verify that. 50 meters in 60 seconds, 30 meters in 60 seconds, 5 feet. Yeah, it's a slightly different number here, but otherwise it's the exact same thing. Okay, so numbers 8 and 9 we're going to skip for now. Number 10. A car is going 55 miles an hour down a straight road. There's a gradual turn. The speedometer reads 55 during the entire turn. Did the car accelerate? Yes or no, circle your answer at this time. And you should have answered yes. An acceleration in physics has a slightly different definition than acceleration in everyday life. In everyday life, we say something accelerates only if it gets faster and faster. If it's getting slower, we say it decelerates in normal language. However, in physics, we don't really use the word decelerate. Everything is an acceleration. Any change whatsoever in velocity is called acceleration. That means getting faster, getting slower, but also changing direction. Because remember, velocity has 2 parts, the number and the sign, the speed and direction. If you change either one of them, you're changing velocity in some way. Number 11, how many centimeters are in a meter? Go ahead and put in your answer right now. Go ahead and do number 12 and 13 at the same time. Hopefully for number 11, you said 100. Number 12 is 1,000, and 13 is 1,000. Number 14, is there an official set of steps to the scientific method? No. I've seen as few as 5 steps in a textbook, and another textbook had as many as 13, and there's all sorts of things in between. I think that when I teach the scientific method, I think I use 7 steps, something like that, maybe 9, doesn't matter. There is no single official set. In fact, you don't even have to use the scientific method and still be a scientist. The most important thing is that you just do things in a logical and repeatable way. Number 15, has a scientific law ever been proven wrong? Now remember that a scientific law is something that has been shown to be true over and over and over again in lots of different situations. They give it a special name then. A law. Has a scientific law ever been proven wrong? And the answer is yes, many times. Just because something has been proven 17,000 times doesn't mean that on this 18,000th time it can't be disproven. And yes, that has happened on occasions in the past. Even the most basic ideas of science can be disproven if we have enough good data. Let's think about one of the most basic ideas of science, and that is how to measure something. You can measure how wide something is, how tall, and how deep. You can't get much more basic than that. 3 dimensions to the world. You have 3D glasses when it comes to movies and video games and all that kind of stuff. 3 dimensions. That's almost as basic as this is up and this is down. How can you get that even can be disproven? Because there's now evidence for there being up to 11, maybe 13 dimensions. We're not going to mention how that can be right now. That's for later on in the class. But even very, very basic ideas, laws, can be disproven. Number 16, can science study something, can study if something is good or bad, like in art, a good piece of art, a beautiful piece of art, or a yucky piece, a well-done sculpture or a poorly done sculpture. Ethics, you know, a good law or a bad law, the proper thing to do or the improper thing to do. Can science study those things? And the answer to that is no. If you cannot put a number on it, then it most likely is not science. You cannot put a number on the beauty of a piece of art. What one person might think is highly skilled, highly intuitive, very, very good art. Somebody else might say that's ugly, I won't give you a plug knuckle for. For ethics and laws, you know, that's the realm of philosophy, politics, theology. That is not science. Science can tell you the effects of laws. Science can tell you how to do some art in terms of how to apply pressure and all that to get a certain look, but it cannot tell you if it's good or bad. Okay, next one. We have an object's location changes 50 meters in 6 seconds. You want to find the object's average velocity. This is like the previous problem above, only instead of the 50, we had 30. Otherwise, it's going to be the exact same kind of a thing. So let's do this step by step. In solving the question above, what variable would you say has the value of 50? So we can see that it has the unit of plane meters. So that tells us that it has a value of x. The variable of x is going to be one of these three. Which one, though? It says that it changes by this much. It's not located 50 meters from any particular place. So therefore, it is not the initial or the final location. It is the delta x, the change in location, the displacement. Number 18, in solving the question above, what would you say has a value of 6? The 6 has a unit of seconds. And so that should be time. Number 19, in solving the question above, what variable are you trying to find? It says finding the average velocity. So we have two V's here. Well, option G has the subscript of AVG for average, so that is the right one. Number 20, in your calculations, what equation will directly give you the answer without further calculations? There is only one equation here that has average velocity. So we have really no options. It's that one. Number 21. Number 21 is not related to the previous few questions. This is standing alone by itself. What do we call the combination of distance traveled and the direction? The fancy word for that is displacement. Number 23, I think this is like number 9 up above. Number 10, no. Number 8 above. An object moves 5 feet below the origin to be 7 feet above the origin. What is the displacement? Okay, so let's expand this bigger and bigger and bigger. 5 feet below the origin. That is where it's coming from. So this is the initial place, x sub I. It's going to be in the future 7 feet above the origin. So that means that this is x sub f, the final location. Both of them are in feet, so that's good. But let's look at our positives and negatives. The 5 feet is below the origin. Below. So that means that the 5 feet should be negative. I'm going to put a really big, thick negative sign there. 7 feet above the origin, above, that would indicate that this is going to be a positive 7. If I just draw a picture of this, See here, we have up and down. So let's do the origin this way, positive going up. It starts off down here, x sub I is -5. Say right there on the number line. And positive 7 is way up here. So you can see then that from way down here, way down at the bottom, up to the positive 7 is going to be a difference of 12. Let's see how we do that with the equation. Delta x is the displacement equals x sub f minus x sub I. Displacement delta x. The x sub f is the positive 7 minus, and the x sub I is a -5. Notice that we have double negatives here. So that means the displacement delta x is positive 7 plus 5, which gets us the positive 12, which is what we said over here. Positive meaning it's going up. Okay, next. Number 24. A car's location changes from positive 20 to positive 50 in 6 seconds. What is the average velocity? Okay, so let's draw a picture of this. We have the car, and it is currently located 20 meters on the positive side of the origin. So x sub I is equal to 20. It moves for a while, for 6 seconds. T equals 6 seconds. And it ends up way over here. And the final location is 50 meters on that side. That's a positive. And the x sub I is positive. Okay, what is its average velocity? We are looking for the V average. Well, what's the equation for that? Let's write that here. V is equal to displacement divided by time. What's the displacement? We don't have that written down. We have x sub f. We have x sub I. We don't have delta x, displacement. We have to figure that out ourselves. $30. Okay, so we put 30 at the top. And the time is 6 on the bottom, so we get a grand total of 5 meters per second. Number 25, we've done already. Number 26, a measurement is reported to be 9 meters per second. Is this a velocity, some version of x, or an acceleration? Circle your answer. Looking at the unit, we see meters per second. That should be a good hint there. Only one of these has a unit of meters per second, or it's just a simple fraction of a length over a time. It's going to be this. Miles per hour would be another example. The per means division. So miles per hour could also be written as miles over hours. Oops. Okay, number 27. A measurement is reported as 9 meters per second squared. Is this a velocity, a version of x, or an acceleration? To answer that, look at the units. Okay, we just said that velocity is a plane fraction of some kind of a length over a time. So it's not velocity. This is over time squared. X's are locations or distances traveled. So that would be just simply meters or miles or something like that. So it's not going to be X, it must be an acceleration. Every time you see meters per second squared in this class, it's going to mean acceleration. And every time you have acceleration, its only unit will always be meters per second squared. It's a one-to-one relationship. One means the other automatically, no exceptions. Number 28 then, you could probably already guess what the answer is going to be. We have plain old meters as our unit. So that tells me that it has to be some version of X. Either it is the initial location, or it's the final location, or it's the displacement, how far it goes. Number 29, an object changes velocity. In other words, it accelerates. It accelerates at -3 meters per second squared. What does this negative mean? It means that the car is being pushed to the left. So if I had a car that is going like this, going to the right, if it's being pushed in this direction, it's being pushed left, it's going to have a negative acceleration and it's going to slow down. However, just because it has a negative acceleration does not necessarily mean that it's gotta be slowing down. Look at this car over here on the left. This car is going to the left. And if I push on it with the same negative leftward force, this car is going to go faster and faster and faster. So here, the negative force gives me a negative acceleration, but that means it's getting faster and faster. Faster. In this case, the negative force, the negative acceleration, means that it's going slower. So do not think that positive and negative accelerations mean faster or slower. No, 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 no. It just means which way is it being pushed on in order to change the velocity. Okay. Now, number 30. Find the time required to push or for an object to change its velocity by 4 if it's accelerating by 8 meters per second squared. I'm running out of time here, so I gotta do this fast. I'm gonna jump right to the equation. We are looking for time, so the t is our unknown. We've got to have an equation with t. We have a change in velocity of 4, so that is a delta v. It's accelerating at 8 meters per second squared. That is the acceleration A. So I need an equation that has t in it, and it relates the t to a delta v and A kind of a thing. So I can do that with this equation. We only have one equation right now that has, nope, we have 2 equations that have A in it. But anyway, here's the one that will work. The other one will not work because the other equation is that really long one. And that really long one has the initial location and final location and the initial velocity in it. And we don't know any of that information. So we cannot use that longer equation. This is the only equation that has the t in it, and everything else we know. So we're going to put in the numbers for everything else besides the t. And I'll get 8 is equal to 4 over t. If you solve for t here, you'll get t is equal to 1/2. To do that, remember, you'll switch the diagonals. So you get t equals 4 over 8. Let's see if I can write that down over here. Switching the diagonals, I get t equals 4 over 8. And that equals the 1/2. Okay, now Number 31, find the car's acceleration if it goes from a standstill to 30 in 45 seconds. So the equation is the same one, only this time we are looking for the acceleration. Find the car's acceleration. So the A stays a letter. It goes from a standstill to 30. So the change in velocity is from 0 up to 30. The change is 30. The time is 45 seconds. And if I do the math in my head correctly, that's going to be 0.667. Okay, I think that the questions in Schoology have a couple more to it that use the long equation. So let me write that down right now, just in case you have forgotten what that long equation is. That is x sub f is equal to x sub I plus VIT plus 1/2 AT squared. So the x sub f is the final location. The x sub I is the initial location. The VI is the initial velocity. The T is the time of motion. The A here is the acceleration. And this T is the exact same T as over here. The time of motion is written in two places, but just remember, one of them has a square to it. The other one doesn't.